Greetings again from China, from my classroom. The irony. So, today, we are going to be discussing lines and special angle pairs. Now, we already know what lines are, so I'm actually talking about a specific type of line, and we'll go over that in a little bit. The objective is that you all will be able to identify and describe angle pairs formed by transversals, and transversals are the names of the lines that I'm talking about. The homework is 3 math space tasks due by Sunday, October 23rd at noon. Now, what we're going over today won't help you too much right now with the math space tasks, but it will get you started in understanding the concepts that you will be presented on video on Monday. So today is Thursday. You will watch one more video on Monday that will help you with those tasks more specifically. If you want to get ahead, what I suggest is that you read over the lesson for each task on MathSpace. There's co-interior angles, which we'll talk about those today. Alternate angles, we will also talk about today. And corresponding angles, which we will also talk about today. Those are your 3 tasks. If you want to get ahead, you should read those lessons. If not, you can wait for the video on Monday. But in any case, you need to watch the video that you are currently watching right now. Now, something I did not mention in my last video, but hopefully Ms. Bays has reminded you. If not, that's okay. But you are able, as of today, to see these notes, and you can follow along with the notes on Google Classroom, which the classroom code is located right over there. Geometry class code 9LQ1R9. Now, if you are not sitting in my classroom right now watching this, then you're going to be really confused at what I'm pointing at, because I'm pointing at something that is on the board in my classroom. Breaking that 4th wall dimension right now. So, just make sure that you are watching this video, you're looking over the notes. If I were you, I would take notes. And that you are, also getting those 2 theorems, Theorem 3 and Theorem 4, done from the day before, or 2 days ago actually. And yes, I'm wearing the same shirt as 2 days ago. This is the only shirt I own. That's what happens when you're poor. So you need to be able to prove those theorems and you turn those in. Then you get started on these math space tasks. You have a week and a half to get 3 tasks done. So you need to do them. Also, important, next Friday, October 21st, you will take a quiz on MathSpace. It consists of 20 questions, and it's about the topics that you will be doing for MathSpace homework. You will have from Friday at 8 a.m. until Sunday at noon, Sunday, October 23rd at noon, to get that quiz completed. So you need to make sure that you take the time on Friday in class to do that quiz. If you are not here, then you need to do it from home or do it over the weekend. Go to McDonald's, go to Taco Bell, go anywhere that there's Wi-Fi. Get it done, because it will be part of your grade. This isn't just a Mr. Jones is gone so we get to sit here and do nothing. You are learning. And I am here to help you via video. Okay, so now back to the lesson. Lines and special angle pairs. We're going to be able to identify and describe angle pairs formed by transversals. Notice, notes aren't too long today, so that's good. So here we go. First, what is a transversal? Well, transversal is a line that intersects 2 or more coplanar lines at distinct points. A line that intersects 2 or more coplanar lines at distinct points. Now I would tell you to put your laptop away, because that's typically what you have to do whenever we're taking notes. However, if you're sitting there on your laptop and you're looking at the notes that are on Google Classroom, that's A-okay. If you're sitting there on Facebook, then you need to close your laptop. Or if you're playing a game, close your laptop. Pay attention up here. Okay? Okay, good. So let's look at what we mean. First, we should pay attention to some key vocabulary points that we have discussed before near the beginning of the semester. Coplanar. What does coplanar mean? You're close. That's collinear. Collinear is when you have 3 or more points on the same line. But this is coplanar. So what does coplanar mean? Yes, coplanar is when you have 3 or more points on the same plane. Now in this case we're talking about lines that are coplanar. That means 2 or more lines that are on the same plane. Basically we're thinking 2-dimensional. We are not thinking 3 dimensions. That's what this is saying. Distinct is different. They're not all intersecting at the same point. They're intersecting at different points. So here we have a line that intersects 2 or more coplanar lines at distinct points. Our line T, so transversal T, is intersecting lines L and M at distinct points. And lines L and M are coplanar lines. So T is our transversal. Now you'll notice 1, 2, 3, 4, 5, 6, 7, 8, those are angle names. And we're going to use those in just a little bit when we go over our special angle pairs using transversals. Something else we need to take note of is what we call the interior and exterior of these lines, because it's going to be very important. The interior is where you're looking at those 2 coplanar lines, so not the transversal line, not the transversal line at all. The 2 coplanar lines L and M. And you're thinking inside of them, like a sandwich. You put stuff inside your sandwich. The interior is inside the sandwich. So the interior of this is inside the sandwich. So these are the lines. If you smushed them together, everything that's between them is the interior. So this is your interior. This side is also the interior. So that is very important. So we've got the interior. So if that's the interior, what do you think outside of it's going to be called? Yes, the exterior. So we've got exterior down here, exterior down here, exterior up here, and exterior up here. So many exterior angles and some interior angles. Now we're going to use all of this information to look at our special angle pairs, using the transversal cutting through these 2 lines. And this is true, whatever we go over today, is true for any 2 lines that are being cut by a transversal. They're not always going to be in a horizontal fashion. They could be in a vertical fashion with the transversal going horizontal. There could be multiple lines with 1 transversal. We're just looking at the basics for now. So, angle pairs formed by transversals. And we're going to keep referring back up to this image. So this is an important image that we're going to refer to for these definitions. The first is what we call alternate angles. Alternate angles are non-adjacent, that means not right next to each other, non-adjacent interior or exterior angles that lie on opposite sides of the transversal. Now I have the interior / exterior in parentheses because I used to call these alternate interior angles and alternate exterior angles. I've taken it down to just alternate angles because when you get to your other tasks on MathSpace, they don't classify them as alternate interior or alternate exterior. Actually, they only consider the interior angles for alternate angles. But I still like to talk about both. So alternate angles, non-adjacent, so they're not right next to each other. Either interior angles that lie on opposite sides of the transversal, or non-adjacent exterior angles that lie on opposite sides of the transversal. So if we look up here, let's start with the interior. We know that they are not going to be adjacent, they are non-adjacent. So no angles like 5 and 6, because those are adjacent. No angles like 3 and 4, because those are adjacent. And we also know that they have to lie on opposite sides of the transversal. The transversal is T. Well, 4 and 3 are on opposite sides, but the definition said non-adjacent, so we can't use 4 and 3. So 4, the only other angle that's in the interior on the opposite side of the transversal is going to be 6. So 4 and 6 would be alternate interior angles. Likewise, 3 and 5 would be alternate interior angles. 4 and 6 are alternate interior angles. 3 and 5 are alternate interior angles. They are non-adjacent, they're not right next to each other, and they are on opposite sides of the transversal in the interior. So 4 and 6, 3 and 5 for alternate interior angles. Exterior, same idea. They cannot be adjacent, so 7 and 8 cannot be alternate exterior angles. 1 and 2 cannot be alternate exterior angles because they are adjacent. We don't want them to be adjacent. Therefore, if they've got to be on opposite sides of the transversal and non-adjacent, then 1, since they can't go with 2, has to go with, well, these are in the interior, can't be them, 7. So 1 and 7 are alternate exterior angles. Likewise, 2 and 8 are alternate exterior angles. So all of our alternate angles, angle 1 and angle 7, which were exterior. Angle 2 and angle 8, which were exterior. Angle 4 and angle 6, which were interior. And angle 3 and angle 5, which were interior. So those are all of our alternate angles, interior and exterior. Next, we have co-interior angles. Co-interior angles lie on the same side of the transversal in the interior. So they are on the same side of the transversal in the interior. You might make note that sometimes co-interior angles are also referred to as same side interior angles. They're actually called that more here, but using MathSpace, we call them co-interior angles. Not cointerior, by the way. Co-interior. So co-interior angles, same side interior angles. If you ever see that, they're the same thing. Co-interior angles lie on the same side of the transversal in the interior. So, they have to be in the interior. So it's going to be one of these, it's going to be some of these 4 angles here, because they're in the interior. They have to be on the same side of the transversal. Since our transversal is T, it can't go on the other side of that. They can't be on the other side. Therefore, very simple, co-interior angles are angle 4 and 5, and angles 3 and 6. So angle 4 and angle 5 are co-interior angles, angle 3 and angle 6 are co-interior angles. Angle 4 and angle 5, angle 3 and angle 6. And then there's just one last type of special angle pair. These are corresponding angles. Corresponding angles lie on the same side of the transversal in similar positions. They lie on the same side of the transversal in similar positions. Now, similar positions is very vague. Sometimes we say in corresponding positions, but I think that's bad definition to use the word corresponding when what you're defining is corresponding angles. So that's why I say similar positions. And I'll explain what this means. Again, same side of the transversal. So if we are looking at our figure, transversal is T. So corresponding angles one set of pairs must be on this side. Another set of pairs must be on this side. They have to be in similar positions. So let's look at angle 1. Angle 1 is on the left side of the transversal and on top of the line that transversal is cutting through. So to the left and on top. So you want to find another point, another angle I mean, that is to the left of the transversal and on top of another line that is being cut by the transversal. In this case, we only have line M. So we go to the left of the transversal and then on top of the line, angle 5. So angle 1 and angle 5 are going to be corresponding angles. Angle 4 is to the left and down. So is angle 8. It is to the left and down. So angle 4 and angle 8 are corresponding angles. Angle 2 to the right and up. Angle 6 to the right and up. So angle 2 and angle 6 are corresponding angles. Angle 3 to the right and down. Angle 7 to the right and down. So angle 3 and angle 7 are also corresponding angles. So those are all our different corresponding angles. Angle 1 and angle 5, angle 4 and angle 8, angle 2 and angle 6, angle 3 and angle 7. Now as a reminder, if you are confused, this is a video. Please pause it, look over the notes, rewind, rewatch. Do this as many times as you need. These videos are available for you to find outside of just watching them in class here. So we have 3 special types of angles: alternate angles, co-interior angles, and corresponding angles. Now these are in general. Come Monday, we're going to go over special properties of these on parallel lines. So be prepared to go over the special properties of these on parallel lines, which is what your math-based tasks are talking about. So again, if you want to work ahead, which I always encourage, then read up on math space and try to do it. Otherwise, just wait for Monday. We'll watch a video. In the meantime, get those 2 theorems done, Theorem 3 and Theorem 4, that you need to write down on a separate piece of paper and turn in to Miss Bays so that I can see that you did them whenever I return from China. The Google Classroom code is on the board, 9LQ1R9. That's where you can find your notes and this video. And other than that, I think that's pretty much it for today. So, have a great day, and I'll see you on Monday. Or if you watch this video again, I'll see you when you watch this. Actually, you'll see me. I won't see you until Monday, October 31st, Halloween. Woo! Yes, I am talking to an empty classroom, but I'm pretending you're here. It's great. Okay, have a great day. Goodbye.